All right, in this video, I want to solve this absolute inequality over here. It's a rational function inside the absolute. So first thing to do is to note that we have a vertical asymptote over there. And our vertical asymptote is at x equals to 3 over 2, or basically that's 1.5 if you want to think of it as a decimal. Now I want to just solve this equation over here, this absolute equation to find the points of intersection between these two functions, and then I'm going to use those x values to prove where this inequality is true. So since I have an absolute, it's going to split into two different equations, a positive and a negative equation. For the positive equation, I'm just going to write it exactly the same, but with an equal sign. And for the negative equation, I'll write this side exactly the same. On the other side, I'll put a negative sign outside the bracket over here, and then I'll have to solve that as well. So let's start with solving the positive one over here. First things first is I'll just make a common denominator on this side to make things a bit easier. So I'm multiplying the top and bottom here by 3. And now I have a common denominator. Then I'll cross multiply both sides. And then I'm just going to expand this out. And I'll bring everything to one side and combine all my terms. So 12x minus 3x is 9x, and then I subtract this 3x when I move it over as well. Negative 18 minus 3 is negative 21. And now I want to factor this. So what multiplies to negative 42 and adds to 6? Nothing really possible over here, which means I have to use the quadratic formula to solve this. So let's do quadratic formula. And then I can just simplify this. Bottom is just 4. Can put the inside there in my calculator. And I get 204. And now I'm just going to use my calculator to simplify this, but if you know your rules of radicals, you can split that up and simplify it. But I'm just going to do this in my scientific calculator, and I get negative 3 plus or minus root of 51 divided by 2. Then I'll calculate the decimal values of these in my calculator. Basically, it's 2.07 and negative 5.07. Those are two of the solutions over there. And the reason why I have decimals and exact values, I'll explain it later when I do my number line, but it's a bit easier to do the number line with decimals because you know how to put the numbers in order. Next, I'm going to solve this equation here. So again, I'll make a common denominator in there. And then I can cross multiply as well. So I know this expansion here will be the exact same as that one there. This is 3x plus 3. And then this is just negative, and then 2x squared minus 3x plus 12x minus 18. Then I'll distribute this negative into this function. So 3x plus 3 equals negative 2x squared plus 3x minus 12x plus 18. Then I'll move everything to the left side, so my x squared term is positive. So 2x squared, 3x will cancel, so this will become plus 12x when I move the 12x over. And then 3 minus 18, that's negative 15. equals 0. So now again, I can try to factor this. My m is negative 30. My a is 12. 5 and 6 doesn't work. 10, 3, nothing really works here again for your man method. So again, we're doing quadratic formula over here. Negative 12 plus or minus root of 12 square minus 4 times 2 times negative 15 divided by 2 times 2. Again, I'll put this in my calculator, what's inside the square root. Get 264, and then again, I'll just use my calculator to simplify this. If you don't have a calculator that simplifies it, you gotta do it manually. It's just negative 6 plus or minus root 66 over 2. I'll convert these into decimals to find out what the decimal values are. First one is 1.06, and then if I change it to a minus, it's negative 7.06. So now that I have all my solutions for the x values of the points of intersection and the vertical asymptote, I can either use a number line or a sign chart to solve this. I'm going to use a number line in this problem. I'm going to draw it quite long because I have 5 different solutions. So I'll start by solving this with the decimal values, okay? So my lowest decimal value is negative 7.06. Then it's negative 5.07. Then it's 1.06. Then it's 1.5, my vertical asymptote. And finally, it is 2.07, which is all the 4 points of intersection and the vertical asymptote included. So now I can test on this number line. So I'm going to pick any value less than negative 7. I'll pick negative 8. And you want to sub it in and check whether this inequality is going to be true or false. So let me sub in a negative 8 into the left side over here. I get 0.37 on this side here if I sub it in. So 0.37, is that greater than equal to, if I sub in negative 8 over here, let's see what I get. I get negative 0.67. So is this true or is this false? Well, this is true over here, which means that this part of the solution is good, it works. That part right there is good. Now let's sub in a value between these two. I'll pick negative 6. If I sub in negative 6 into the first equation, I get 0.33. And if I sub in negative 6 into the second equation, I get 0. So is 0.33 greater than or equal to 0? Yes, it is. So this one is true as well. Let's pick a value between these two. I'll pick 0 because 0 is easy to do. If I sub in 0 into the first equation over there, I just get positive 0.33 again. And if I sub in 0 into the second equation, I get positive 2. So is 0.33 greater than equal to positive 2? It's not. So that range there is not good. Then I'll pick a value between these two over here. I'll pick 1.1. If I sub in 1.1 into the first equation, I get positive 2.625. I'll just write it as 2.625. 6. If I sub in 1.1 into the second equation, I get 2.3. That's true over there. So this range over here is basically good. And then I have to test between these two values. So I'll sub in 1.8. If I sub in 1.8 into the first equation, I get 4.6. And if I sub it into the second equation, I get 2.6. So again, this interval here is true. And then last, I want to sub it in a value here. I'll just sub in positive 3. So if I sub in positive 3 into the first equation, I get 1.33. And if I sub it into the second equation, I get 2.4. So 1.3 is not greater than or equal to 2.4. So that one's false. So now we have all our solutions over here. We just have to combine them for our final solution. So over here, since it's inclusive in the main equation and equal to sign, that means that vertical asymptotes are going to have round brackets because they're non-inclusive, but our solutions will have square brackets because they're inclusive. So my first solution is negative infinity to negative 7.06. But since this is a solution, I can include both of these together. So I can go from negative infinity all the way till negative 5.07 because this answer here is inclusive. I'll put a square bracket over here because negative 5.07 is also inclusive. For my second solution, I can't group these together because my vertical asymptote is here in the middle, which means that I have to split this into two different ones. 1.06 is going to have a square bracket because it's a solution, but 1.5 is going to have a round bracket because it's a vertical asymptote. And then I have this final range here, which is 1.5 till 2.07. I'll squeeze it in there, and 2.07 is going to have a square bracket because again, that is a solution. It's not a vertical asymptote. So that is my final solution to this question here. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.